Welcome to video 1 of a 3-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. Today we will be going over how to complete exercise number 1 found in the National Water Model Notebook number 4 titled Retrieving Archived National Water Model Forecasts from Google Platform or GCP storage with Hydrotools. To access National Water Model Learning Module, type in hydrolearn.org. This will take you to Hydrolearn's main page where you can search National Water Model and click on the icon to access the learning module. You should now be at a page that looks similar to this one. This video assumes that you've already worked through the introduction as well as section 1 and now have a brief understanding for what the National Water Model is and understand why it was created. Section 2, and that you have understand now all the different outputs of the National Water Model, such as the short, medium, and long-range forecasts, as well as the analysis and assimilation. This learning video will be in learning activity number 2. Alright, we're in learning activity number 2, accessing National Water Model through Python code. Now this page should look very familiar if you work through all exercises up to this point. If not, read through these instructions and you'll get set up with Hydroshare as well as the Jupyter Hub notebooks. We're going to click here. And we're here. We're going to click on Open with Quasi Jupyter Hub. And it is opening. All right. Now that we're here, your page should look something like this. If it doesn't, as long as you can see these 4 notebooks, you're good. We are in the National Water Model Notebook number 4, or Hydrotools. Perfect. Hopefully before completing these 3 exercises in the 4th notebook, you've already worked through notebooks 1, 2, and 3. They somewhat build on each other. You can work on them out of order, but I highly recommend going back to the previous videos because it'll help build your knowledge. If anything, I definitely work on notebook number 3 before doing this notebook. Alright, notebook number 4 says Retrieving Archived National Water Model Forecast from Google Cloud Platform Storage with Hydrotools. Okay, so if you've already done notebook number 3, you know that we use this link right here. Should look familiar, to get to the Google Cloud Platform where we're able to go and download data all the way back to 2018, September 2018. All that data was there and available for us to take, but we had to do it manually. Well, in this notebook, we have code written up that will go do it for us. We just have to put in the date and some reach IDs, and it will go do everything we need. So we don't have to go in there manually and put it in a folder and everything. So this is not too hard. Just follow along, and we'll try to work through it. The first exercise states: search online for a large storm or flood event for a major river sometime in the last few years. Retrieve a forecast for the river, the Google Cloud storage near the event date, and plot it. Retrieve another forecast for the same reach a couple months prior to or after the event. Compare the two. How much larger was the flow during the event that you found? Hint: you'll need to retrieve forecasts from GCP for the correct dates and subset them for the desired reach ID. You can get this from the stream gauge map above. Alright, perfect. Alright, not too hard. So first off, we need to find a large storm event. Now I'm picking a really easy one. I just went to the flood list and I found one that today for me it's May 19th, 2022. Now, please, when you're doing this exercise, don't pick the same flood. Actually, today I'm not even going to completely go over this exercise because I'm hoping I don't want to just give the answers, but I am going to provide enough information to figure it out. So we have a flood that happened in West Virginia Um, Emergency declared after deadly flash floods in West Virginia. You can see pre-catastrophic. Perfect example for what we're doing. So this happened the 8th of May. It happened the 6th of May, 2022 in Huntington, West Virginia. All right, so we're going to use this flood event that happened recently, and we're going to come up here, and we're going to start running through our code. So we're going to install our packages. There we go. It's running. It'll take just a minute. It's actually going to Hydrotools and importing the tools that we need to be able to do this. Pretty interactive stuff. So, there we go. We're going to come down. Now, we have several different ways to do this, just like in Notebook 3. We could use nomads, which we know only holds data till the day before, whether your current day and the previous day. That's it. So we could use this, but for this exercise, it's not going to be as helpful because we want data that was, I don't know, a couple years ago. In the example I'm going to use, it was 2 weeks ago, but still we can't use nomads. So we're actually going to skip this code. Don't need it. And we're going to use the Google Cloud platform code. So we're going to come in here. We're going to hit run. It's going to specify our service that we're going to use the National Water Model data, GCP, configurations, all that stuff. All right, so this is where the meat and potatoes of this exercise is at. This is how we're going to get it done. Now, notice up here all the options we could put in. We could put in long range, medium range 1, member 2, member 3. As we know, the long range forecast has 4 members that are produced, and the medium range forecast has 7 forecasts that are produced, and the short range forecast just 1. So you can put all these things in there. For this purpose of this exercise, we'll just do the short range forecast. It'll generate a little quicker, but I invite you to play around with that. It's kind of fun that we can look at all the different members, and remember that a member just is a prediction of what the forecast is going to be in the future. So in the quick case of the short range forecast, it only goes 18 hours in the future. Medium range goes out to 8.5 to 10 days in the future. And long range goes all the way to 30. So the long range needs more members, and it does, for 16 forecasts, and it just provides a better average of what probably is going to happen in the next 30 days. Anyways, all right, we're going to come here. We're going to do configuration, short range. Short range is perfect. Now the reference time. This is really important. So if we go back to our example. We're in Huntington, West Virginia. This happened the 6th of May. So we got to come in here, and I got to put in the date that it happened. So 2022 happened May, and it happened on the 6th. Now these following letters and numbers, so T00Z, just tells it when to take the short range forecast from, like what time of day. A great explanation is provided right here. Exactly what you could do T01Z, you could do T00Z, that's what we have, T06Z, and it's just telling it if it wants to start like at 3 a.m. Ours, for example, is going to start at 1 a.m. the UTC time zone for the specified day. So it doesn't really matter for what we're doing here. All right, so we're going to come in here, and this is still nomads. Okay, here we are. So we got that put in. I'm happy with that. We're going to hit run. And we're going to hit run here too. It's going to wait just a minute, but now we have a pandas data frame. So we're going to see a pandas data frame come up here in just a minute. Organize all our data for us. Love pandas. Provides it just a quick and easy way to see all of our data. There we go. It looks good too. Alrighty. So we have for this date all of the short range forecasts throughout the United States. All of them. Now, we only want Huntington, West Virginia, right? So we're going to come down here, and we're going to help the code narrow down as a little bit where we want to go. So we got subset data frame, And what we need to do is we need to come put the reach ID in right here. So subset data frame tree forecast for indicated reach. And the way to do that is we're going to scroll down here. We're going to skip a little bit of code, and we're going to use the USGS stream gauge network. Read through this. This is really good information. But Hydrotools essentially uses the USGS stream gauge network to provide content. And essentially what we need to do is we need to use this code. So we're going to run this, and it's going to give us a map. Now we're going to scroll right in here to West Virginia. Let's see if we can find it. Huntington, West Virginia. There we go. Along the Ohio River. Now there's stream gauges in particular spots, and what we're going to do is we're going to find a stream gauge somewhat close. So we have this one, so we'll just use this one. It looks like it's feeding into that, so it should be correlated. And we're going to copy the feature ID, not the object ID, nothing like that, but the feature ID. Control C. And then we're going to come back here and, scroll back up. We have the date still. Okay, subsetting plotting, here we are. And we're going to switch out with the reach ID that's already in there for that one. The feature ID, reach ID, same words. All right, so we're going to hit run there. Hit run there. Looking good. Now all we have now is the short range forecast for that feature ID, which is awesome. We're going to hit run. Now this stuff is going to set up a graph for us. You can change things up here if you want, but it's already coded for us, so we just have to hit run. And there we go. Now, this exercise does ask you to look at this event as we can see now, and then also look at that same one at a different date and compare the two and see the difference of how fast or what the stream flow is. I'm not going to do that today. In order to complete this exercise, you do need to do it. So I highly advise that you take the time and do it. But what I'm going to show is enough to get you started. But we can see here on this graph that it plotted what we're looking for. You can see it's the 6th of May, and you can see indeed there was some type of flooding going on because the flow rates went extremely high. So there's some pretty crazy stream flows that were going on, and it's already dropped down pretty quick. So this is just a quick example of how to do this exercise. It just asks you to be able to look at it and compare, and be able to pull out and know how to do this. So hopefully this was enough information to be able to go through this. Just remember the key points is that you got to come in here, you got to choose what kind of forecast you want, the date. So you're going to look up a major weather service, a major flooding event that's happened sometime since 2018, and because that's as far back as the data goes, right? September of 2018 to be more accurate. You're going to put in the date there, and then you're just going to put in the feature ID close to that event using this map. And yeah, that's really it. I guess if we wanted to do this maybe a little bit better, I'll give a little bit more help. So this is what is happening. We see the highest flow rate right here was about 6.4. So then if I wanted to compare it to the regular flows of it, maybe I'll just bring come back up here to the date, and we'll change the date to, let's do let's do the 8th of 2021. Let's do the 1st. All right, so we'll run this, and we should see If I run it all the way down, let's give it a minute. We'll be able to compare and contrast what was going on. It'll take just a little bit to go get the URL and everything. Find exactly what we want. There it is, there it is. And there we go. You can see that it was super low. And look, the highest point was 1.0. So indeed, there was a huge flood going on. The 6th of May, 2022. So pretty cool to see that this is real stuff. This isn't made up. You can go see real weather events that have happened and really plot them and see exactly what was going on. So hopefully this helps. Please feel free to get creative. You can do whatever you want with this. You can change up the code even if you want and plot different things. You can change out how the graph looks. So that's enough for this activity. We'll move on to exercise number 2 coming up next.